We are back and better than ever. And today we are talking about linear inequalities in two variables. It's going to be fantastic. All right, here we go. We are going to first learn how to graph an inequality before we show you the applications of graphing inequalities. There's one at the end here. So we're being asked to draw the graph of x plus 2y less than 4. So we're looking for all of the ordered pairs x, y, that when put into this equation, substituted in for x and y, give us a number that's less than 4. Okay, so how do we do that? Well, first we're going to graph a line. And the line we're going to graph is x plus 2y equals 4. Okay, and we can usually do that. We can easily do that by this particular form using the x and the y-intercept. So to find the x-intercept, I'll let y be 0. So that would be x plus 2 times 0 equals 4. So x would equal 4. So I have 1, 2, 3, 4, 5, 5. I have an x-intercept of 4. And let's see, for the y-intercept, I'm going to let x equal 0, so I'd have 0 plus 2y equals 4. 2y equals 4. Divide both sides by 2. Oops, I don't know what that was. Divide by 2. And y is equal to 2. So along the y-axis, 1, 2, 3, 4, 5, label my graphs. And there we go. And now we're going to draw a line through those 2 points. But we have to be very careful because we have to look at our inequality. Since this is less than, the line is not part of the solution. And to indicate that, we have to use a dashed line. Oops, I need to go to my line things. Okay, gotta remember I did that. Okay, so and we already have a line, and let's make it dashed, and I'll make it pink just for fun. Okay, so I'm going to try and go through these 2 points as best I can. Let's see, 2, 5, 2, 1, 2, 3, 4, 5. So let's try here, 4, 2, 4. So we'll start here, and we'll go like that. Okay, now I'd like to draw it all the way down here. Okay. Now this is an inequality, so we got to test it out. We don't know if it's going to be on this side or this side, all of those ordered pairs. So what we do is we pick a point, a test point. And if I can pick 0, 0, I'm going to use that every single time. And all I'm going to do is substitute it. Oops, see, I forgot there. I need a solid line now. I'm going to substitute it into this equation. Is 0 plus 2 times, actually this equation, that's bad, the inequality, is 0 plus 2 times 0 less than 4. Well, 0 plus 0 is 0 less than 4. And the answer is yes! So that means everything on the same side of this point is part of the solution. So I would shade everything on this side. You don't have to color it all in. I guess you can if you want. But everything on this side, and now we have to kind of pretend we know the line's going to go that way, is part of the solution. If this had not been true, like if this had said 0 is greater than 4, then I would have shaded the other side. Okay. Next question. Draw the graph of 2x minus 3y is less than or equal to negative 6. So again, I'm going to think of this. I'm going to graph the line 2x minus 3y equals negative 6. Okay? And so I'm going to find my x-intercept by letting y be 0. So that would be 2x minus 3 times 0 equals negative 6. So then 2x equals negative 6, and x would equal negative 3. So 1, 2, 3, 4, wait, 1, 2, 3, 4, 5, just to get some scale here. 1, 2, 3, 4, 5. Make sure you have a scale. So that puts negative 3 right here. Okay? and then the y-intercept, and we're going to let x be 0. Don't need my name tag. And so that would be 2 times 0 minus 3y equals -6. So divide by -3, and we get y equal to 2. Okay, and that's right there. Okay, and then I need to go to my line again. Okay, but this time, if you look, it's less than or equal to. And that means the line is part of the solution. So to indicate that, I use a solid line. Okay, so 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, maybe about here. We'll see how that does. Ooh, I'm getting better at drawing these lines. Okay. All right, so there's our line. Now the question is whether or not the solutions are on this side over here or this side over here. So I'm going to use my test point. 0, 0 is nice. So let's see, 2 times 0 minus 3 times 0. Is that less than or equal to -6? Is 0 less than or equal to -6? And the answer is... let's see, is 0 less than -6? No, it's not. So that means that everything on this side, on the other side, needs to be shaded. Okay? Make sure you understand that. I use the test point 0, 0 right here. And I replace x and y with 0. And I found out that 0 is not less than or equal to -6. So that is the wrong side. So I shade the other side. So all points here on this side of the line and included on this line are solutions to this inequality. Okay. Draw the graph. Y is less than x. So I'm thinking y equals x. I'm going to graph that line, and this is of the form y equals mx plus b. It's just that my b is 0 and my m is 1. So the y-intercept is 0 and the slope is up 1 over 1. That's simple. It's less than, so my line is going to be dashed. I'll make it dashed again. And let's see, here we go. It's going to look like that. Okay, I can't use 0, 0 as my test point, so maybe I'll use, oops, wrong thing to do there, sorry folks. So maybe I'll test maybe, let's see, 1, 2, 3, let's do 3, 1, it's just out of the way there. So 3, 1, right? So the y coordinate is 1, the x is 3. Is 1 less than 3? Replacing it here, and the answer is yes. So this is on the correct side of the solution. So I'm going to shade everything on this side, indicating that these are all of the solutions. Okay, last example, and I will be quiet. And that is this one, lawnmowers. A company manufactures X walk-behind lawnmowers and Y riding lawnmowers per week. The maximum number of lawnmowers the company can manufacture in a week is 25. A. Write an inequality in two variables that represent this problem. So the sum of the lawnmowers, X plus Y, the two different kind of lawnmowers, cannot be more than 25, a maximum number of 25. So it has to be at the very least less than 25, but 25 is included. So we're going to say less than or equal to. Okay? And so then we're going to graph that inequality. And so we're going to find out, okay, x plus y equals 25. Okay, and the intercepts I think are pretty simple, because if y is 0, the x-intercept is just simply 25, x equals 25. And if x equals 0, 0 plus y equals 25, y equals 25. Okay, so let's see, I'm going to say that each of these are worth 5. So 5, 10, I'll make this 10. So that's 10, 15, 20, 25 here. And I'll make this 10, 10. So 5, 10, 15, 20, 25. So there we go. And it's included, so I'm going to have a solid line. Just keeps going back and forth on me here. Okay, so we're going to start here. And, oh, I thought I did a solid line. I did not. So let's make that a solid line since it is included. And we are going to go, let's see, from here. We're going to draw that line through those points. Very good. And, oh, we didn't even make it a line. Sorry about that. That's okay. And so it has to be less than or equal to 25. So let's do a quick test point. 0, 0 is my friend. That's right here. Is 0 plus 0 less than or equal to 25? It is. So our solution set would be all of these guys. But what we need to understand is, since we're talking about number of lawnmowers, we are only talking about the integer ordered pairs that we can use. Okay? And then we have to say to ourselves, hey, wait a second. I can't make negative lawnmowers. I can only make positive numbers of lawnmowers. So the possibilities actually are only within here. And I can't make part of a lawnmower. I can only make, like 1 or 2 or 3 or whatever kinds of lawnmowers. So any whole number ordered pair within this little triangle would be the solution to this problem. Hope you enjoyed it. I certainly did, and we will see you next time. See ya!